Today we're going to get introduced to Python's implementation of a min heap called heapq. And the problem that we're going to walk through is to find the kth largest element in a list. So let's say we have this list right here. It's fairly long, it's unsorted, and we have to find the second biggest element in this list. So a really naive but simple way to do this would be to just sort the list and then return the second item in that list. But maybe there's something that we can do with a little less overhead. That's still, relatively simple. So luckily, we have a data structure called a heap. And what a heap does is a heap lets you keep track of the minimum or the maximum of a list at any point. And that depends on whether it's a min heap or a max heap. So if we are finding the smallest element in a list, kth smallest, we'd want a min heap, but we want to find the kth largest element in a list. So Python's heapq is a min heap, but kind of like an easy way to get around that is to just multiply every number by -1 right before you put it in the heap. So let's go ahead and build the heap first. So for num in nums, heapq dot heap push heap num. Okay, so now we've built the heap and we have access to the min of this list. The max of this list. So if we remove the max of the list, we'll have the next max of the list. Max of the list in its place. So let's do that k times. So k. Let's just keep popping the root node off. Heap. Yeah, that looks right to me. And once we do that, and we'll save it too, we will have our kth biggest element. So like I said, we have to make sure to account for that -1, and once we do that, we should get the right answer, which is 43, I believe. So once again, kind of all this problem is asking, do you know what a heap is and how to use it? And if you don't, check out this Python module. It's a little strange. It doesn't seem like it's super well fleshed out, but it gets the job done.